All right, guys, welcome to Chapter 2. This is a pretty brief lesson on Section 2.1, which deals with writing and graphing inequalities. So we'll take a look at that. Here we go. So like I said, Section 2.1, writing and graphing inequalities. There's a GeoGebra link and an exploration that we'll do in class. All right, so first thing here, writing linear inequalities. An inequality is a mathematical sentence that compares expressions. So all about chapter 1 was dealing with equations, and chapter 2, the primary focus is with inequalities. So you'll see a lot of the things that we're doing is very similar to what we saw in chapter 1, with the exception of a couple things here and there. So first thing, we have to know our inequality symbols. This is one of the areas where people struggle the most with. So we have our two less than symbols and less than or equal to symbol right there. You can kind of think of the less than symbol because it sort of resembles a squished down L. Some of you might have used like an alligator or something like that, but you have to know your less than and your greater than symbols. All right, so we've got our less than symbol, and key phrases go with that is less than is fewer than, and then when we've got the line underneath, that line right there, that's our less than or equal to symbol. So you might hear less than or equal to, at most, no more than. That would be examples of the phrase that can go along with that. Then we have our greater than symbols, which are here and here. I'm going to use a different color actually for those. So we've got our greater than symbols as well, which are here and here. Okay? Is greater than, is more than, is at least would be an example of greater than. So don't get confused on that one. But make sure that you know your symbolic notation as well as the phrases that go along with both of those. So let's look at a couple of examples of writing inequalities. All right, so in each sentence, we'll write an inequality to go along with that. A number w minus 3.5 is less than or equal to negative 2. So we've got a number w minus 3.5 minus 3.5 is less than or equal to, so there's my less than or equal to symbol, negative 2. So the key thing here is knowing that that symbol right there represents less than or equal to. And letter B, 3 is less than a number n plus 5. So that's what that would look like. And finally, 0 is greater than or equal to twice a number x. So 2 times x plus 1. Okay, so it's important that you're able to translate what's in words into mathematical notation, as we've done here. And there are the solutions like we just did. Next thing that we want to look at, and this is a key thing here in the notes, I'm going to highlight it, is the difference between an open circle and a closed circle. So an open circle is used when a number is not a solution, and a closed circle is used when a number is a solution. So your key things that you need to know, and make sure that you're writing this down, is that your less than or your greater than will use open circles, okay? And your less than or equal to and your greater than or equal to will use closed circles, because when you have a less than or equal to or greater than or equal to, that number, that's your boundary point, can be a solution to your equation. So if we want to see in letter A, what is this exactly saying? It's saying y is less than or equal to, we wrote it in words, so any value or any number that is less than or equal to negative 3 would be a solution. So now we have to graph our inequality. When you have to graph the inequality, create a little number line. Here's 0, positive 3 would be over here, negative 3 would be over here. So in our solution here, we're going to do it in blue. Because we've got that line underneath there, it's going to be a closed circle. And what values are solutions here? Anything below -3. So we draw our solution like this, which represents that any number at -3 or less than -3 is a solution. So what are possible solutions here? Well, -3 is a possible solution. -8, -100, -1,000,000, they're all solutions. Now, if we look at B, one thing I want to make note of, if we read this out loud, we would say 2 is less than x. Not sure why that keeps happening. So 2 is less than x. We like to have our variable on the right-hand side. So let's spin this around, and we can make this way. X is greater than 2. The reason we like it this way is then you can kind of use a little cheat and look at which way your inequality symbol is pointing. That cheat only works when the variable is on the left-hand side. So let's draw in our number line. We've got 0 who lives here, -2 lives here, 2 is here. Notice no line underneath, so it's just going to be an open circle, and we're going to shade to the right. Is 2 a solution here? No. Why? Because we have an open circle at 2. Final problem here, x is greater than 0. Here's my number line, here's 0, open circle at 0, shade right. Anything above 0 would be a solution. Okay? This example, we'll take a look at in class, dealing with an application type problem, as well as the error analysis we'll look at in class as well. Okay, so key concept summary here. We can see in words what a problem would look like, a linear inequality, the algebraic representation, and then the graphical representation. So you have to be able to move from one to the next. And in this particular problem, you can see they're all starting at 2, but depending on the inequality symbol and what the words represent, they're doing different things. So x is less than 2, we see what the graph looks like there. X is greater than 2. Notice both of these, no lines. Open circle, open circle. When we have the line underneath, we've got closed circles and closed circles there. So just make sure that you're able to kind of go from one representation to the next. All right, that's all for today's lesson. We'll go more into inequalities in the next few sections.